long enough. It was not long enough. I had like 2 days where I wasn't catching up on grading things or planning things or anything like that. And that was used to make Halloween costumes or SpongeBob costumes. So nice. So we have 29 more school days until Thanksgiving break. 6 weeks. Okay? We're getting there. So those of you that haven't written it yet, this is week 10 on the Bellwork page, so please put that at the top. It really, really, really helps me so much when looking at the Bellworks. If you will put the week number at the top where it says week and then it has a blank, put the 10 right there on that blank next to your name. Those help too. I have a surprising number of Bellworks get turned in without any names on them. Like, you look at this page 5 days a week, theoretically. Should have your name on it. Who's lying? All right, so let's take a look at this. If we're trying to write an equation for this line, it goes through the point 0, 3 and has a slope of 6. How are we going to do that? What's this equation going to look like? Y minus 3, because remember this is my x and this is my y. And since this is a specific point, this is x1 and y1. So this is y minus 3 equals 6 parentheses x minus 0. That is our point slope form. There should still be a y and an x in an equation. Just like we have y equals mx plus b, y and x stay there. So the y and the x that do not have any little baby numbers, stay there. Very similar vibe on the right-hand one. Again, I'm giving you a point. This is telling you our very specific x1, y1. So when we write the right-hand one as an equation, what are we going to get? I'll start us out. Y. Yeah, we're going to go minus negative 3, which gives us a plus 3 equals what? 8. Gorge. X minus 3. Just like that. So we worked a lot with point slope form right before we went to break. So I know it's been like a week since we thought these. And my iPad is at 25%. So I'm going to just plug in for most of the time. But questions on these two. They're not super long or calculatory difficult. It's just a matter of remembering. Okay. So what we're going to do today is a lot of review. Or it's review that's going to be very, very relevant here tomorrow. And what it's most important that we remember how to do is graph a line. So, as I said at the very beginning, I've been fighting with the technology all day, so we have our beautiful graphs. Aren't they so pretty? It's like textured, fancy, expensive paper, but not. So, I'm going to pass these out just because I didn't feel like making a bazillion and a half little bookmark baby graphs with a can confetti all day. So, we're going to do it as like a little worksheet together. Ooh. So, I probably are not actually covered in my loose toner, but they are so beautiful. On my to-do list today to figure out what that kind of happens to do. So we're going to remember how to graph some lines. Some of them are in slope-intercept form, some of them are in standard form. None of them are in point slope form, but I wish they were. That would have been a great job. But, you know, hindsight. So it's not going to be a super duper intense, or at least not super duper mental day for us because, we're first day back. It is 7 o'clock in the morning. We probably have not seen 7 o'clock in more than a week. Unless we came at it from the other side. So we're gonna remember how to graph some lines, and we have a few different strategies we can use, but we are gonna be using these tomorrow when we're working with the rest of this module. We are gonna be graphing lines, and it's gonna be super important that we graph them properly and accurately, which means our most important tool, ruler. I'm gonna put some rulers out. And I'm busting more out here. The rest of my gear on these tables, but I'm gonna put that marker in the box. What's up? It happens. All right, so all we're going to do today is graph some lines. So, when we're given an equation like this, where we've got my x minus y, my x minus y equals -3, what can we do to be able to graph this thing? This one. This is number 1. What can we do to make this something we can graph? Subtract x from both sides. Absolutely valid. That puts us into slope-intercept form very nearly. So I'm going to take I'm just going to write the whole thing over here. X minus y equals -3. And we can absolutely subtract x from both sides. Totally fine, 100% valid. What's that going to leave me with? Ooh. Minus y equals minus x minus 3. Lots of minus signs here. Ew. What do we need to do next? Not divide by y, but super duper close. What's in front of the y? Negative. So what number is that? -1. So I need to divide absolutely every piece by -1 because I don't want minus y equals. I need y equals. Divide by -1. Divide by -1. So we're going to get that y equals minus x divided by -1 gives me a positive x. -3 divided by -1 plus 3. So how do we graph this? Where do I start? On the +3 on the y-axis. So I find my y-axis, that's the up and down one. Yeah, so I've got my y-intercept at 3. That's that B. You could. Our slope, our m is 1, which means we go up 1 over 1, up 1 right 1, up 1 right 1, or we could go down 1 left 1, down 1 left 1, down 1 left 1. Either way, the more dots you plot, the easier it is to connect them up. It is critically important, not even kidding, has to be a thing. You must use a ruler. Not optional, not me being petty. I promise, it's important. When we graph lines, go from edge to edge on the grid. It doesn't matter that it doesn't go from wall to wall. This is still going like across the corner here. But I have gone all the way to the edge of the grid on the paper. Please, go all the way to the edge. It will make a difference when we get to what we're going to be doing with graphs tomorrow. Rulers, edge to edge. Very important. Because tomorrow we're going to do more than one graph on each of these. Not these specific, but we're going to do more than one graph on each graph. That is absolutely a valid option for what to do. 100% totally fine. So our plan on this one was, this was switch so what we did here is we switched this into our y equals mx plus b form. That is an option. It is not the only option, but it is an option. And you can use that strategy absolutely every time if you want to. You don't have to, but you can. Honestly, all the rest of them are kind of gross to do any other way. We can do that same thing over here. Absolutely valid. What would we do here to be able to graph this one, number 2? What could we do for this one? What can we do here to be able to graph this thing? What would be our first step? Subtract the 8x. Yo. So we got our 8x plus 5y equals negative 25. I'm just writing it over here because it's really hard to fit it in that space. So we can absolutely subtract 8x from both sides. Absolutely valid. That's going to leave me with 5y equals minus 8x minus 25. Again, I just like to squish the x in front of the constant just so that we wind up with our mx plus b situation. So I just squished them in front. So what do we need to do next? But it's a negative. Which we do that how? How do we get there?
We leave it. We have to take divide by y.
Divide by what? 5.
Wait,
Divide by 5, divide by 5, divide by 5. Everybody gets divided by 5. So the 5s cancel out here, so we're left with our just y. That's what we wanted. Does negative 8x divided by 5 simplify at all? No. So I'm just going to write it as negative 8/5 x. How about minus 25 divided by 5? Minus 5. So now we're into our mx plus b. So where are we going to start? It's my first point. Negative 5 on my y-axis. How do I find my next point? That's my b. We're going to do the whole thing, yeah. How do I find my next point from this one? Because normally we would say we would go, down 8 and right 5. But I could go up 8 and left 5. That's still going to give me my negative slope, my downslide. But then I don't go off the graph because I'm way at the bottom. So if I go up 1, 2, 3, 4, 5, 6, 7, 8, and left 1, 2, 3, 4, 5, that still gives me my negative slope. This line looks like it's going to go downhill. And I still fit on my graph. So sometimes there won't be a ton of points that fit on our grids. But it is still important that we do as many as we can. Woo! We connect them up. We try not to close all the tabs on the iPad at the same time. We use a ruler. We make a straight line. And there's arrows on either end. Boop. Like that. So there's our standard form stuff. We can put them into slope-intercept form. We could go through and find XY intercepts to do that if you really want to. Like, that is absolutely valid. More often than not, we are going to do slope-intercept form just because it's something we are really familiar and really comfortable with. So there are 2 more standard form questions on the front. And on the back side, it's slope-intercept form. Like, it doesn't even have anything fun, fancy, crazy with it. Okay? So I want you guys to keep working on that. And what I'm going to do while you're doing that is I'm going to pass back all the things. I've got your skills checks from the day, like the Friday before break. I've got all the homework stuff. And I'm going to work on passing that back. What's up? Yeah, let me actually pass. Give me a second. What's up? When you're done, yeah, turn it in. And then I'm going to work on passing stuff back. And it's going to be a mess, but it's going to be a mess. And then if we have time at the end, or if you want to, we can talk through the skills check stuff. But really, I wanted us to kind of see that and get that feedback before we got too far into the rest of this chapter. But also didn't want to make today too obnoxiously heavy in things because we are just working on getting back into the habit of waking up. All right. As long as I don't make bad choices, I don't have any, like, that's the benefit of being on the high school side, not the freshman side. I can trust y'all a little bit more. Because Ms. Hannah's got to be, like, real strict with stuff, because freshmen are crazy. That is called A Weeping Angel. It is from Doctor Who, because I am that level of nerd. It's a British sci-fi TV show.
No, I've heard of it.
This one is also from Doctor Who.
What's your age go?
Now with the little orange monster. Good.
It.
Technically, it's a pound of body fat. But he's a little alien and he walks around and he's super cute. It's called an adipose.
Wait, I was actually putting up. Wait, 942. Oh, yeah, I did that. Where you go out here?
You good?
Yeah.
You're good. You're doing great. Okay, these around. They're very similar. To be fair, I did not design the worksheet. One of the other teachers did, but I agree, they are incredibly similar lines. Put in bucket, yep.
Got what?